Good day, students. I'm Harvey Dino. I hope you are doing good. For today, we will tackle the topic intermolecular forces of solids and liquids. Let us first have a look on the kinetic molecular model. The kinetic molecular model explains the properties of solids and liquids. As we all know, kinetic means energy in motion. This model shows how molecules interact together through intermolecular forces. For this time, we will tackle the intermolecular forces of attraction. So what is intermolecular forces of attraction? This force hold the molecules together, which can be attractive or repulsive. These intermolecular forces are accountable for the properties of substances. Moreover, intermolecular forces also explain why substances exist as solids or gases at room temperature. As what you can see from the picture below, the intramolecular forces hold the atoms of H2O together, while the intermolecular forces hold H2O or water molecules together. We have four types of intermolecular forces of attraction: the dipole to dipole forces, hydrogen bonds, ion to dipole forces, and London dispersion forces. Dipole to dipole forces exist between polar molecules. Recall that polar substances such as hydrogen chloride (HCl) are those that possesses a permanent dipole moment, attributed to the difference in electronegativities of their component atoms and how these atoms are arranged in space. Knowing that a molecule that is polar has an unequal density of electrons that result in a partial positive and partial negative, such as in the example of HCl molecules below. Hydrogen bonds. Hydrogen bond is a special type of dipole to dipole interaction that exists only in molecules that contain a hydrogen atom bonded to a small, highly electronegative atom such as nitrogen, oxygen, or fluorine, meaning that if an atom is more electronegative, it attracts the electron to it and have a relatively charge of partial negative of neighboring electronegative atom, such as in the example of NH3 or ammonia below. Ion to dipole forces. Ion to dipole forces acts between an ion either positive or negative and a polar molecule. Such is the case for the aqueous solution of sodium chloride, when Na and Cl ions are dispersed amidst polar water molecules. It is also said that the ion dipole degree depends on the charge and size of the ion, whether it is a cation, which is a positive ion, and an anion, which is a negative one. From the example, the chlorine atom, which is a negative atom, connects to the hydrogen atom of water and sodium molecule, which is sodium attracts to the oxygen atom of water. Lastly, we have London dispersion forces. London dispersion forces, or simply dispersion forces, are intermolecular forces of attraction that exist between all atoms and molecules. Moreover, these are only forces acting in nonpolar molecules. They arise from continuous movement of electron in particles. Nonpolar molecules have zero dipole moment because their electron density is uniform and symmetrical. Nevertheless, the electrons have some freedom to move about the molecule. Therefore, at any instance, the molecule momentarily acquires a non-uniform electron density, resulting in a temporary dipole, also called instantaneous dipole. Again, we have tackled the four types of intermolecular forces, which are the dipole to dipole forces, hydrogen bonding, ion to dipole forces, and London dispersion forces. For dipole to dipole forces, we have to remember that it exists between polar molecules. In hydrogen bonding, it is an interaction that exists only in molecules that contain hydrogen atom that is bonded to a small and highly electronegative atom. Next is the ion dipole forces, which acts between an ion either positive or negative and a polar molecule. And lastly is the London dispersion forces that acts only in nonpolar molecules.